Friends, today I'm going to talk about the Leetcode 1186 maximum subarray sum with one deletion. The problem is, given an array of integers, return the maximum sum for a subarray with at most one element deletion. It also doesn't allow the subarray empty. So let's give an example here. Here we have array equal to 1, minus 2, and 0, 3. And in this, we could delete minus 2, and it will become 1, 0, and 3. So for this subarray, we get the maximum subarray, which is still the same, 1, 0, 3. So the sum of the maximum subarray is 4 here. So the problem is that actually means that we are allowed to delete one element at most. So that is, we can delete one element, or we don't delete any element from this array. So there are two cases, and for the first case, that is we no deletion here. That is actually the same problem with the maximum subarray sum problem. That actually we can use dynamic programming here. The idea of the dynamic programming is, for this array, we assume and actually the answer for this array is 3 here, which is the maximum subarray. And so we could define a DPI indicates the maximum sum achieved and up to the index I from index 0. So we will find that the DPI, it will depend on the two situations. The first situation is that if the previous element plus the current element is bigger than the current element, we will assign this summation, or else we will assign this. So it's actually we get the max of these two here. So this is the transition function of this dynamic programming, and the output will be the max of DP here. So this is important to solve the deletion problems. And secondly, if there is one deletion here, so naive way, that is, we delete every element from this array and call the algorithm of sum. Delete the array. Delete each element from about array and call the algorithm above. Actually, the algorithm here is the is a famous Cardan algorithm, if I remember correctly. You can check it out and find out the details about this name, Cardan algorithm. And so we can call the Cardan algorithm here. Actually, we can confuse them, these two steps together. So we will define a algorithm called node delimiter. We call the node delimiter, define an array called node delimiter. That is the same as here. Indicate the max sum until up to index R. Index R without deleting any element, and the other array R that indicate the maximum sum up the index with one element. So with one element deleted. Therefore, we can update this this second array when we update the first array. So it's actually that for the first delete array is the same as this one here. So it's here is we can call it previous one plus current one, and also connect here. Then how do we update this here? This is actually dependent on also depending on two cases. The first case is that there's one element deleted. If there's one element deleted, we will know the maximum value will be dependent on the previous I-1 node deletion array. And also, if the current element is not deleted, or is deleted, doesn't matter, but it's node deleted, it will depend on the previous this previous one element array. If no element is deleted, then we plus the current element here. So we get the maximum of these two elements. So this is basically the function of here. Then output will be the max of these two here. And we also have to consider the how do we initialize these two arrays. So the first array we could of course we could initialize as the first array 0, and if there's one element delete, there should be the empty here. But in this question we are asked we should return non-empty array. We could also return, and we could also define the array first element to initialize it. So basically this is the idea. So we have just return it from once, from 0 to n here. So the time complexity here is O1 here, and also the space is also O to n equal to On. Of course, we can also reduce to the O1 if we use one element to replace these two arrays. We use replace array because it's only depending on the previous one element I-1, so we can define two variables to replace these two arrays. But here I'm going to write function of this, use these two arrays here. So let's write a function here. So first we define this two array here. Define this node detail. Before we define, we make some corner case. If it's empty, we return 0, or it's only one element here. I return the element in this way as answer. And we initialize the maximum here, the minimum value here. Then we initialize this two array. What happened? We initialize another array here. Then we iterate this array. We only need to start from 1 here, and we update this, so we can copy this function here. And also another element is over here. And we can define also the maximum here. So in this, when we iterate, we can update during the process. So we get the max of this 3 max. And we return this max. Okay, here there should be the float, because it could be return negative values here. So okay, this works. Let's try another test case. 5 another test case here. Yeah, we made it.